Welcome back to the Automation Podcast. My name is Shawn Tierney from the Automation Blog and School. And in this episode, I meet up with two folks from Rockwell Automation, Armand Prezioso and Chris Stearns. And they come on to tell us all about their brand new line of highly available distributed I/O, FLEXHA. Now, before we jump into the podcast, I do want to give a shout out to our sponsor for this week's episode. Every week, it takes several hours to produce an episode of the show. And so I want to thank theautomationschool.com for choosing to sponsor this episode. If you know anybody who needs PLC, HMI, or SCADA training, please send them over to theautomationschool.com. And with that said, let's learn all about FLEXHA distributed I/O. Armand and Chris, thank you for coming on the Automation Podcast. I'm really looking forward to learning all about FLEXHA 5000. This is a new line of distributed I/O from Rockwell. This doesn't happen every day, so I'm excited to have you guys on the show. And if you don't mind, could you introduce yourselves to our audience before you jump into the presentation?
Sure. Hey, Shawn, first, thanks for inviting us, right? This is an exciting time for us, launching a new product, and it's greatly appreciated we get some time with you to discuss it. My name's Armand Prezioso. I've been at Rockwell 23 years. I'm a product manager in the I/O group, and this is one of my new product developments. It's called FLEXHA 5000. Chris, tell me something about yourself.
Hi, thanks. Like Armand, I'm a global product manager for our DCS offering here at Rockwell Automation, and my name's Chris Stearns. I've been with Rockwell for about 5 years at this point. Thanks, Armand. Back to you.
John, so I'm going to go through introducing FLEXHA 5000 and keep it kind of technical and brief. I hope you have some questions you can ask that we can share with the audience. First, just an overview, right? The FLEXHA 5000 I/O platform was really designed for the DCS market, for the process industry, right? And the HA stands for high availability. So we're achieving high availability with this I/O platform, which we're really excited about. We'll probably be in the 5 nines area if you're familiar with the availability calculations, right? Those are typically done for SIS systems, but we did the calculations for the basic process control system as well, which is exciting because some customers don't need safety, but they want high availability. So that's kind of the root of the HA, the high availability platform, right? So the first release of this platform will be what you see. It's going to be a universal I/O card only for standard control, for basic process control. And then in the future release, you'll see us get the SIL 3 with this product. Standard and safety can be intermixed on the control rail. Now, that sometimes is a customer preference, right? Sometimes they don't like the mix. They like diversity. They want to keep it separate. Both modules can be in simplex or duplex. So even though it's a high availability system, you can actually have the power conditioners, the adapters, the backplane, all that stuff can be redundant and high availability, right? But the I/O can be a mixture of simplex or duplex. So in some cases where you might have some loops that require redundancy and require that availability, you can use redundancy. And then on the other cases where you just need some simplex I/O or maybe balance of plant or non-critical operations, you can use it in simplex and have the same card, the same platform, the same spares, right? That's one of the unique things about this platform. Each adapter pair, so I'll talk about the rail master base and the adapter base and so forth coming up, but each adapter pair can have 24 modules. Okay, so and it can be mixed and matched and split up and so forth, but 24 modules out of the gate, so you get 192 points in simplex or 96 points in full redundancy, or somewhere in between if you mix them up like I was discussing earlier, right? So what makes this architecture high availability and simpler for customers to use is every aspect of the system is redundant or can be redundant, like the I/O. I said you can do simplex or duplex, but from the backplane, the power conditioners, we'll go into details of all the individual components. All those components are redundant and that they can be maintained while running. So the nice thing about having redundancy is, let's say, for example, adapter A. Adapter A fails, adapter B is still running. And while B is running and your system is running, you can change and replace adapter A, keeping your system up and running, right? So these are really meant for 24/7 operations, people who want to run We usually go into 10-year range. So we do our calculations, we do it for 10 years. That's kind of the design behind this. But once again, you can use that simplex type IO, right?
Now, I want to break in here just for a moment to thank our sponsor, theautomationschool.com. If you need training on control logics or compact logics, including using distributed I/O, plant PAX, VFDs, and whatnot, please check out their courses over at theautomationschool.com. And with that said, let's get back to the show.
One of the other nice things about this platform is wiring is not disturbed when replacing a module. So in some platforms, even in some Rockwell platforms, right, you have to pull the wiring harness off and then replace the module behind it. In this case, the maintenance folks do not have to do that. The module is remove and insert from the Z-axis. That means pulling it straight out to you, right? And you can go ahead and replace that module and get it back up and running. So all the components on this platform, and you'll see a bigger picture later, are remove and insert from Z-axis. They all are also re-up. I don't know if you're familiar with re-up. If you're a Rockwell person, re-up stands for remove and insert under power. So you can remove these modules, replace them while it's still running. Ability to remove during runtime or to remove modules during runtime and Z insertion are two of the key aspects here. Also, it can be mounted horizontal or vertical. So from all the platforms that Rockwell has, if you're familiar with control logics or compact or even the standard FLEXIO, FLEXIO is the only one that can be horizontal or vertical mounted. So this platform will follow suit with it. And then extended temperature range, -40 to +70 C when mounted horizontal. And then some unique features I'll talk about later with the media landing cards, but the first release will be, copper RJ45s for networking, and then we'll come out with SFP versions as well. But really just to recap, right? So DCS focused for this IO delivery platform, universal IO and high availability, lots of diagnostics. Current sourcing is important as well. Current sourcing has to do with the fact that you don't have to split your wires off and wire them to different terminal blocks and wire in a power supply. You're going to land your power supply on our IO base, and then we're going to make sure that the instruments get powered downfield, right? And then obviously our analog support HART, and then we'll support two of the Rockwell networks that are for high availability, and that's PRP, Parallel Redundancy Protocol, and DLR, Device Layer Ring. That all will be supported with the first release.
Now, just for the audience who may be very familiar with Rockwell's previous offering, what would you see this as the replacement for, as the next generation of which existing line?
Yeah, good question. So this would probably be a replacement for 1715 IO.
Okay.
We've had that IO platform for some years now, right? Probably more than 10. But this is not a replacement for it now, and I'm not sending a message that it's going away. We have longevity levers. If you're familiar with PLC5, we're still maintaining that platform, right? And we announced that a long time ago. So Rockwell customers, I think they're well aware of how we like to support products even after we announce they're going to discontinue or to come towards the end of their life, right? To show you kind of the roadmap, I told you we had some work to do, right? The first release 1, is going to exist of the universal IO card. So that's the U8HFTXT. It's an 8-channel universal card, Shawn, that can do analog in, analog out, digital in, or digital out, software configurable. So you could buy a panel full of all this hardware and figure out what your IO count is later. And we'll talk to some of those advantages of using the universal IO card in doing a project while using the universal IO card. Some of the other modules you'll see here, I have kind of the roadmap or Armand's wish list of, hey, this is where the platform is going to go in the future. And there's more than this, but I don't like to put too much on the page and people get confused about what's coming up next, right? But some high density cards. I look at the market for IO, Shawn, as I have the people that like traditional IO. That's the IBs, the OBs, the IS, the OFs, right? And then I have the people like the universal IO. And so I like to keep it different. Now, in some cases, traditional IO folks might use a universal IO card for spares, right? If you ever seen specs or requirements that, hey, I need 10 or 20% spares. Kind of hard to do that with 4 different types of I/O modules, right?
Mm-hmm.
But if
Yep.
I can give you 20% of your universal and use it however you want to use it, then it's a little more flexible for you. Also on the communication side, we'll have the adapter and we'll have a media landing card. And this media landing card is a new thing for Rockwell. Usually the adapters have the connections for the media right in them. In this case,
Mm-hmm.
we've broken that out so that customers can have the flexibility of changing. I'll go into some more details about that on the next slide. But really, the first release will be the RJ45. That's kind of the most common. And then we definitely are going to get into the fiber and SFP range within the next year and a half.
One thing for the audio audience is all of these modules have XT at the end. So I'm assuming that means extreme temperature. That seems to be Rockwell's XT. Is that correct?
Yep. So we're in this range where we're in between a few things here, right? So extreme temperature, -40 plus 70. We're also conformal coding these.
Nice.
So in some of our I/O lines, we had the standard module, and then in the past, depending how new of a customer you are, how old of a customer you are, we have something called CC. Those were conformally
Mm-hmm.
coded. We've done some research and made some changes, and we call those K modules now. So
Mm-hmm.
you have the catalog and then a K, and that's where we conformally code them. In this case, there's not K written on here, but I don't have a standard and a K, right? These are all conformally coded.
That's nice.
So
Simplifies
yeah,
things. Yeah.
yeah, simplifies things. I own the 1756 product line as well for I/O,
Mm-hmm.
and I have, I don't know, 80, 70 modules, and then I have a K variant of those modules. I got 140, right?
Mm-hmm.
And it's very hard to maintain and support and so forth. So one module, it does everything. It can be simplex or redundant. It's conformally coded, and it has a temperature range. So some of the other things, besides kind of the little roadmap here that I want to mention that are very key aspects here. It works with L8 redundancy only, right?
Okay.
So you need to have an L8 controller, and it obviously includes the P controller, the Plant PX controller. That's a must. And also, as far as the adapters go, it's the EN4TR. So it's the latest adapters as well. We're doing something, and it was on the slide before, but I want to mention it here, is concurrent communications. Later on in the slide deck, I'm going to talk more about concurrent communications. Our controller redundancy folks are very familiar with our processor redundancy, and that's an N+1 type redundancy. And just a little details for the technical folks, right? So the IP address, the primary is going to be a .0, say, at the end
Mm-hmm.
of the IP address, right? And the secondary is going to be a .1. And whenever there's a switchover from primary to secondary, we switch those IP addresses in the background. So the new primary, which was a secondary, becomes .0.
Mm-hmm.
And the old primary is now the secondary, is .1. And that keeps everything aligned as far as messaging and so forth. But it also has a little bump in there. And I don't remember the time. I'm not the redundancy person, but there is a little bump, right? In this case, we're doing something called concurrent communications. So both adapters, even in the controller chassis, and the two adapters in the I/O chassis, are constantly communicating to their own adapter and their own processor, and they're constantly getting updates. So when the controllers do a switchover, they already have the information. They've already had it. There's no bump. There's no IP swapping. None of that stuff. So it's something new in this platform. Pros and cons. It has a lot of redundancy features. Cons are we have some products today that don't speak concurrent communications. We'll be working on bringing those products and having that capability in those products in the future. But there's some gotchas in the architecture that I'll discuss in a network architecture section of this presentation.
All right, before we get into that, I do want to talk about two products from our sponsor, theautomationschool.com. PAC Basics is their Control Logics course, and Compact Basics is their Compact Logics course. Now, when you enroll in either online course, you get lifetime access and support. So if you have questions on anything you're learning, you can ask them 24/7, and their instructors are there every workday to answer your questions. That said, if you do buy the extended edition of either, that's the level 2 edition of either course, you get the new 2023 edition, which I'm beginning to film right now. So please, if you enjoy this podcast, this episode, and you'd like to learn more about Control Logics and Compact Logics, please visit our sponsor, theautomationschool.com. And with that, let's get back into the show.
I'm going to go into a system overview where I'll talk about the individual components in a little more detail, right? A little technical, so you understand what we've done with this product, what the pieces and parts are, and so forth. I'm going to start to the left, and that there, if you're familiar with 1715, it has a catalog number of A2A. Well, A2A was a 1715 adapter base as well. So I kept some of the catalogs so that you had the familiarity with 1715 and the 5015. So that whole base that it's sitting on, minus on the right, is another little base that is attached to it for expansion. Okay. This slide is showing expansion. You don't need to. You can do all these in a row. Okay, but it gets quite long. But the first adapter base, left to right, the first two things are power conditioners. So that's going to take a standard 24-volt power supply, say from our 1606s. You're going to bring power in. You're going to wire them separately. So if a wire were to fall off, it doesn't affect the system. Right. So here comes that high availability stuff and redundancy stuff. Right. And each power gets wired to each power conditioner, and that controls the backplane all the way down to rail. Okay. The next two, they have a little purple hue to them. Those are our adapters. Remember I said the adapters don't have any media landing on it. And that's the two modules behind it, below it are called the media landing cards, the MLCs. And that, Shawn, is so that people can mix and match the media types. Oh, I bought an adapter with RJ45, but what I really needed was fiber. Now I got to exchange that whole adapter. It's pretty expensive, right? Or use it on a next project. In this case, you can just buy the media landing card, which is less expensive and fault tolerant, just like the rest of the system. And you can switch those out.
Yeah, and you don't disturb the wiring.
And you're not disturb the wiring.
Exactly. Yeah, I get it.
Any of the adapter, you're not pulling modules out hot, right? So it's kind of unique, and kudos to the hardware and firmware engineering team at Rockwell that we've had challenges during COVID. Everyone has on getting design work, getting through certifications, getting components, and so forth. And the team has done a great job with helping us design and get this product out the door.
So this A2A base, right? So this is your starting base. It's like this is always going to be on the leftmost side, and this base mounts to a back panel, a metal back panel mounting plate, right?
It's a metal mounting plate, absolutely. It's much larger than typically you would buy the mounting rails for terminal blocks, right? So aluminum mounting rails, similar to that, right? But much larger. This system, like I said, mounts from the front, the Z axis. It does if you wanted to, you can actually add a new IO base online while it's running and not disturb anything else that's running. So there is a little tilt to it, but we've designed a system that you can put it into that rail, slide the next base in, and then start adding your IO and configuring it and so forth online. So you don't have to take anything down to do it. So it's kind of another unique design considerations that, hey, we want to make sure customers can add on to this product as it's going through its life cycle, right?
But I guess the A2A base, right, it seems like it's always going to be the same. You're going to have two power conditioners and two network adapters, plus you'll have your media landing cards. The wiring, the terminal block, it looks like is that a removable terminal block underneath the power conditioner module?
It is. So there's three terminal blocks there. Let's touch base on that real quick, right?
Okay.
So you see some slim ones, right?
Yep.
And that's where you mount your external power supply coming into our power conditioners, right? So that's meant for 24 volts. So customers, maybe using our 1606s, obviously we're going to recommend and test those, right? But you're going to land your 24 volts there. The larger one in the middle is actually the same terminal block that we use for our single or simplex IO, right? And what we did here is, so in the past, I did a lot of things for Rockwell. I was in sales. I did some engineering stuff and so forth. But every time you make a panel, you always have to bring some digital inputs in and maybe one digital output. So you might want things like door open, or you might have a temperature switch inside there that has a contact that closes. All our 1606s have DC OK contactors that close. Some of our our network adapters, or not network adapters, but network switches also have that DCOK. And you can bring 16 dry contact inputs in through the adapter base and bring it into the Plant PX system and diagnose what's going on with that cabinet without using any of your IO points.
Okay, that makes sense. Yeah.
Yep. So that was one of the things, like I said, every time I designed a panel, it was always, well, I have a 10 slot chassis. One of them is going to be used for the diagnostic inputs. I only have
Yeah.
9, right?
Yeah.
So that was the thought around it. One thing to make sure I mentioned is this adapter base that we're talking about. It can handle up to 6 quad IO bases, which means 24 modules. You know, we were talking about that earlier, how we can support 24 modules. And if it's universal, it's 8 points. So that means it can be 96 if they're all redundant, or 192 points if they're simplex, right?
Okay.
Or somewhere in between. And that's only because this first release is an 8-point card.
Yeah.
Once we start getting to higher density cards, IV16, OB16s, right?
Mm-hmm.
You can obviously do more points per adapter base.
And you don't need the bank expansion, bank expansion, unless you need to split the rail up, whether you're like one on top of another or one in one enclosure. Can you go very far between them? Like you do back to back?
Yeah,
I mean,
it's just a 2-meter cable, and actually there's
Okay.
4 of them. And the reason there's 4 of them is because 2 are for the backplane and 2 are for the power.
So redundancy.
Redundancy, and we made them individual instead of one big cable, so that if, let's say, one of your power cables goes bad, well, you still have the other one, and you can maintain and run. Just go change that one cable. You don't have to change them both. You don't have to take the system down, right?
Another good thing about that too is, I've seen many installations where they put them back to back, and they have to put all the cables through a pipe. And when you made a really big fat connector, it's hard to get a big enough hole to put that through. So having the 4 smaller cables would be advantageous for that. And again, if you're going to top bottom, running it through the Panduit, right, or the wireway.
Absolutely. Yep.
Better if they're small, thin cables with a connector on each end than one big honking. I know that was always a problem with some of the previous products, right? So no, I thought I liked that.
To bend it.
Yeah, so that's what it feels like sometimes. Yeah.
Right.
So all right, so this makes sense. This makes a lot of sense. And all the modules here for the audio audience are separate from the terminal blocks. So on the base, you plug in the IO module, but you also have on the base a terminal block, kind of like FLEXIO, but it doesn't look anything like FLEXIO, but kind of like that. So you can swap out cards, adapters, power conditioners without disturbing any wires, which is awesome.
Correct. Yeah. So let's talk about that quad IO base for a second.
Okay.
Right. So after you had those bank expansions, you can see that there are 2 slimmer bases that go down to plug the cables in, right? And then you start that quad IO base. There's a little thing on the top I want to talk about. It's called the backplane interface module, and it's also on the adapter base. It's to the right of the adapters. There are 2 little small modules that those plug in. They have lights on them. There's plenty of diagnostics. They are removable and insert under power. What that did is that removed all the backplane components that we might have had on some of our other products. So the backplane is truly traces, right? So there's no components on the backplane that could fail for you. We moved them all into those modules that can be replaced. So once again, going into that high availability, fault tolerant, keep it running, let the maintenance folks be able to change things while it's running, and don't leave a single point of failure that would bring down the whole chassis, right?
So every single chassis, whether it's the adapter base or backplane, the quad IO base, they have 2 redundant pair of these backplane interface modules. Are these all the same? Is it like just one BIM?
Yep, there's one part number.
Awesome.
They're all the same. You can mix and match them. It doesn't really matter. I will tell you, as we're talking about, oh my God, all these components, right? One of the other things I heard when I was in sales is that, hey, when I get my stuff from Rockwell, I get all these boxes. And I have to open all these boxes. I get all this literature, I get all this stuff. The very first thing I did when we start putting catalog numbers and so forth is I made kits. So I have an adapter kit, Everything comes in the adapter kit except for the MIDI landing cards because I don't know if you want fiber or copper.
Okay,
But
yep.
all the RTBs, the backplane interface modules, the power conditioner, the adapter, all in the kit. One part number. Your adapter base is taken care of except for the MIDI landing. And then the IO kit, I do something similar, but it's not as much, right? So I do the IO or the IO base, quad IO base, and the two backplane interface modules. Then you're responsible for picking out the IO and the terminal block for the IO. I
Got
do give you the SA power, where you land the SA power, and I'll go over that here in a second. I do give you that one, but I don't give you the regular terminal blocks because I don't know if you want simplex or duplex. So even though the terminal blocks, and this is the other thing, I'm the 1756 product manager. So, when you look at that IO family, how it was developed over the last 24 years, I think is when we started. You really have to have a secret decoder ring if you go from an analog to a digital, right? Even inside some of our analogs, right?
IAB,
Right.
baby.
IAB and wiring diagrams and so forth, right? Anyway, with this platform, universal IO, IB, OB, they're all going to be wired the same. And in the universal IO, if you're wiring an analog in, analog out, digital in, or digital out, and it's a 2-wire type device, you land it on A and B all the time, whether it's a digital in or digital.
That's nice.
So you don't need a secret decoder ring. If you're doing 3-wire, you can still land 3-wire on this terminal block, and we tell you where to land them, whether it's an analog in, analog out, digital in, or digital out. If you're doing 4-wire, same thing. So we wanted to make sure that, for people commissioning, doing the wiring, doing the drawings, and maintaining it, it was easier for them than what we've done in the past.
Can you talk a little bit about the Shield terminal block? I've seen that on other products, but of course not on 1756. So can you just give us just a couple seconds on that?
Yeah, absolutely. So the Shield terminal block, we introduced that with the 5094, the FLEXHA, right?
Okay.
That's where if you need a shield, in the past, I can remember, all right, I'm going to land an analog cable, right? And I'm going to have to peel this analog cable back about 2 feet or 3 feet. I'm going to have to land my 2 wires for analog, and then I'm going to pull the ground or the shield ground over to some other terminal block somewhere else in the panel. So my wiring in a wireway, I got a bundle of shield wires going over somewhere that I have to land, and I got all my wires going up my IO. And then if you look at some of the requirements that we get from other customers, right, it's always each shield has to have its own landing. So if I have 192 points of IO in a system, or 96, I have to have 192 points for whatever I have shielded. Some people shield DC and analog, right? But nonetheless, that's their preference. You have to have a shield for each. In this case, we made it so you only have to peel back the wire to get to the terminal block, and you can wire to the terminal block and then wire to the shield right below it, and we take care of the grounding for you.
It looks like the Shield terminal block sits directly on the mounting plate. Is that correct?
It does, yeah. So what it does
is
it's an add-on. It's not always there. You only need it if you're using shielded cable, and there's some rules around shielded cable, analogs, and so forth, right? And when you do, then you can put one of those on there, screw it down right to the bottom rail. You'll see the ground lugs are also screwed down to that bottom rail.
Yeah.
You'll screw that shield terminal block down, and you'll land your shield. You have one location for each 8 points, and away you go. So it keeps your wiring a little neater, keeps your wireways clean. You don't have to strip the wires back so far. All right, let's go into some of those terminal blocks down there. I wanted to talk to you about the SA power. That's actuator power or field power. You can have all kind of terms for it, right? But we're gonna power the loops and 2-wire control. So when your instrument needs 24 volts, all you do is land on that small strip there. It's just the same terminal block that you have for the adapter base for the power conditioners. Same part number, everything. You land your 24 volts. The module picks up 24 volts from there. It isolates it per the channel because these are all isolated cards. And we're going to supply the loop power out to the instrument, whether it's an analog in, analog out, digital in, or digital out. The other nice thing about it is, and I'll show you maybe a different picture of this later, but at the end of this rail, and I apologize for the audio audience, but there's another little slice there, and that's a cover because it's the end of the rail. So we just covered up that. But you can land another SA power there if you wanted to. You can also land a jumper that's already done for you. It's a plastic part that expands over to the next quad IO base because that SA power rail can handle 20 amps. So
Oh,
what you do is
nice.
an analog. So you don't have to keep on landing SA power. You can land a redundant power supplies once and then jumper down the rail. If you want to individually fuse and power each quad IO base, you absolutely can. If you don't want to, you don't have to.
So 20 amps, that's quite a bit. That's good. That's good. I know.
When you're talking analogs, absolutely, or 24-volt DC inputs or outputs, that's a lot. But when you start getting into high current DC outputs, or when you start getting into high density
Mhm.
digital outputs, you're probably going to have to be forced to go to landing DC power there. If I give you 8 amps per card on a DC output of 16 channels, you can get to 20 amps pretty quick, right?
Hey, so quick question on that plastic cover on the end. Does that
Mhm.
come with the adapter base?
Yeah. So the kits have everything you kind of need, and I strategically put parts and kits that I think you would need for a whole system, and I strategically left stuff out of just a quad IO base so that you weren't throwing parts away.
Mhm.
So the SA Power blank or the SA Power cover comes with the adapter base. And the
Good.
reason for that is you're always going to have an end of the rail somewhere. And
Yes, exactly.
I'm giving you one. Now, I don't know if you're going to have an end of the rail per quad IO base, or if
Mhm.
it's just you're going to go, 3 quad IO bases, you have the end of the rail. I'm going to give you one with the kit, and then you can buy them as you want to buy more SA powers.
Yeah, that's good. It's like the end cap on some of the other product lines. You always
Correct.
needed one,
Yep.
and that was always great when it was included, like with the brick PLC, the L23 or something. So, all right, good.
Yep. And then, okay, so let's look at the regular terminal blocks for a landing field wire real quick. The first 2 universal IO cards are set up in redundancy to be fault
Okay.
tolerant. If you look at that terminal block, it is spanning between the 2 modules.
Mhm.
To the left and right of it is an A and a B. That's just writing, right? Laser etched, right? Pointing to the module saying, your module A and your module B, and land your wires in the middle. We're going to take care of wiring the instrument to both modules. You don't have to do any fancy work. You land your modules for 0.0. We're going to go to 0.0 for A and B module. We're done. If you look at the next RTB, that one does not have the A and B on the side of it. It's directly underneath the next IO card. That is for simplex. They both wire the same way. Column 0, points A and B are for channel 0. The simplex, same thing. You land the wires the same way. So there's no difference between redundancy and simplex when wiring. It's the same thing. No secret decoder ring again, right? The next IO card is a spare, and there's no base there. There's another cover. This is just to show that we have covers for all the RTBs as well.
So is this the 2 terminal blocks are identical except for the covers they come with?
Where you land the wire is identical, but the terminal block for the redundancy is twice as wide. It just has some gray space at the bottom. When you push it in, it spans both IO terminal landing points.
Okay.
But when you see it, it's easier to understand.
Got it. Yeah.
Yeah, but the nice thing to get out of this really is we have a redundancy block for landing field wire, and we have a simplex block. They both get wired on the field side the same, right? There's no secret decoder ring, but one of them is going to span 2 modules for you, so we can take care of the wiring under the hood, and one of them just goes directly to the module that it's under.
So for
And
the
then
audio audience, they look identical, but one has an A and B cover on the left and right of it, so it takes up 2 spaces. But as far as where you put the wires in, they look identical. But one spans 2 slots, as he said, and one spans 1 slot. And you're saying these both wire identically?
Yep, absolutely. So
That's
channel
awesome.
0, 2 wire, like I said, there's in this block, there's 8 columns and there's 4 rows. And the columns are 0 through 7 for the IO points that are 0 through 7. And then the rows are A, B, C, D. And our documentation will tell you for 2-wire control, plus on A, negative on B. And that's just true same for whether it's redundant or simplex.
So now I'm thinking ahead to the IBOB. Same blocks?
Same blocks. And if
Okay.
we get 16 channels, what will happen is A and B will be channel 0. And you'll go A and B 0, 1, 2, 3, 4, 5, 6, 7, right? And then you'll go down to C and D at 0 for 8, 9, 10, 11, 12, 13, 14, 15.
Makes sense.
Okay. And those will be 16 channel. They'll be 2-wire only, right? If
Yeah.
you do have a device that is 3 or 4-wire, we'll give you a path to do that, but we'll be sourcing power for those.
Good.
Trying to think if there's anything else on the slide that I can think of. Pretty much covered it. I don't know if you have any questions about it or. Oh,
No.
there's one thing.
Good.
Here you go. Go over to the power conditioner. There's LEDs underneath that power conditioner. They look like little gray boxes and so forth, but those LEDs give you the diagnostic information coming in. So, they'll turn orange when they're initiated and so forth.
Okay.
Well, for the universal IO, there's actually 24 LEDs there, but they're laid out in analog out, digital in, digital out. And depending how you have that card configured, you can see how that point is configured by the LED.
Okay.
So let's say you have 0.0 configured as an analog. It will show up there green saying, hey, I'm configured. And it will turn orange when it's on. If none of the rest of those LEDs are lit or on, the rest of the channels are not configured. So as you start configuring channels, let's just say you wanted to make 2 channels analog in, 2 channels analog out, 2 channels digital in, 2 channels digital out, the appropriate light will be lit for each one of those channels. So you get the diagnostic information, right from that LED in front of you.
So you don't even have to open up the software. You know if a channel on that card is digital, analog, etc., just by the indicators.
Correct. Absolutely.
Nice.
Yep.
Nice.
You can walk up and see that, hey, I have a digital in my hand that I need to land. Are there any free digital ins? Oh, yeah, I can see that. Channel 6 and 7 are digital ins and there's nothing there. I'm going to plug mine in there. And you just go tell the engineer, hey, I landed, that temperature switch on channel 7.
Nice.
Also above, there's some LEDs going across the whole platform. So you'll see the typical LED for, the system okay or module okay light, right? We have that on everything. You'll also see some additional ones. You'll know if your backplane A and B are working or if you have a problem. So you can diagnose backplane issues just by looking at the front of it. You'll know if it's set up for redundancy or if your redundancy is healthy or not between the 2 modules. So quite a bit of diagnostic information right on the front. They'll also tell you about SA power. Maybe you have an SA power problem and you don't see that SA power light on. You can then say, hey, we got a problem with our power supplies. So you're not wasting time kind of sitting there with a meter and trying to check out what's going on.
This may seem like a silly question, but what's in this the white box at the bottom of the module? It's too small for me to make out. Is it a logo or is it a QR code?
That's a QR code. Yeah, so we have QR codes for all of our devices, so you can walk up to it, hit the QR code, and get the catalog number and the technical data for it.
That's perfect. Awesome.
So on this next slide, we talked about the power conditioner, 1606s and so forth. I had this in there for detailed information for customers. You get a 1606 that meets your power requirements, whether you have AC in or DC in, and then you can wire it individually, 2 separate power supplies. In this case, one going to the left power conditioner and one going to the right power conditioner. So you're maintaining that fault tolerance, not only in the IO platform, but you're also maintaining it in the power supplying the IO platform. Right? It wouldn't make sense if you put one conditioner out there and have all this redundancy in the IO. And also have the recommended power supply for that power conditioner. And the same for SA power. SA power gets a little funner. I don't know if you're familiar with our redundancy devices for our 1606 line, but in this case, you have 2 power conditioners and 2 diodes. You can have one or two, one of each of those things fail and still keep redundancy going to the IO rack. And then also this shows that jumper I was talking about between the 2 bases. I call it out there. It says SA power jumper. So notice you're landing your SA power at the beginning of the quad IO rail. and you're continuing it through the second quad IO rail as well.
Nice.
So this is showing 2 quad IO bases.
And redundant power. Using just your off-the-shelf redundant. This isn't a special, this is your 1606 line. It's not a special 5,000 power supply, which is nice.
Nope. Yeah, standard 1606s. Right. This bank expansions, we mentioned that, and we mentioned orientation, right? So this is showing you how those bank expansions can work, how you can orientate the hardware in a horizontal or vertical distance, right? Now, I don't want you to think that you have to do it this way, right? This is showing 2 quad IO bases. If you add them up, there's a total of 6. I don't care how you make those rails, which one's longer, which one's shorter, right? You just got to make sure you have enough room for your cabling and so forth. And you'll notice one of these is kind of wiring to the left, and the other one's wiring to the right, right? So you don't have to bring it to the middle. You can have your field wiring on the outside where you can get some more room into it, right? And keep the IO close, back to the IO close. But this kind of explains the banks. You can have up to 3 banks. So if you count them 1, 2, 3, that's all you can have. But we're not giving you any limits on the number of quad IO bases per bank. Let's jump into networking a little bit, because I mentioned that concurrent communications, and I mentioned PRP and DLR at the beginning of the presentation. I'll have some slides here. This is a PRP network. It has redundant power supplies on the redundant controller chassis, and it has an EN4 TR in there. It has the black cabling lines are going to it, right? You have 2 separate network switches, and they both, if you follow that, both of them go to, it's not at the bottom where the media landing is. I should probably do that, but both of them are going to both adapters. So you have 2 paths from both adapters going to both adapters and IO continuously, right? So there's no IP swapping. So this is an example of PRP. Just reiterating, the EN4TR is the only one that will work with concurrent communications. And L8 controller and L8P in particular are the controllers that you need to have for 5015.
Yeah, just to throw out there, the switches, you have to have PRP in the switch to do this configuration. It
Absolutely.
will not work with a regular switch. You would actually get some errors, lots of errors. It wouldn't work.
You need to have a switch that's familiar with PRP. Absolutely.
Yeah. Yep.
The other thing I didn't mention is version 35 and forward.
Okay.
So
yep.
Version 35 of Logic Designer is already out, right? It's been out since November, and you can go in there and see the IO in there and configure it and so forth, and you can see how you can change the IO from analog in, analog out, digital out, digital in, pretty seamlessly. Matter of fact, towards the end here, I'll give a link to the landing page for 5015, and on there is a video showing you how to do it. All right, next, the good, the bad, the ugly. Right now, the only thing that speaks concurrent communications is 5015, right? If you want to put logics in with a 5015 system, you have to have another adapter and the controller chassis. That one will speak non-concurrent, and then the other one will be configured for concurrent communications. They can reside on the PRP network. They can reside on the DLR network, but one adapter is talking to 1756 and the other adapter is talking to 5015.
That's important to know, that you're going to have you're going to have an EN4TR dedicated for your FLEXHA IO today.
And eventually you're going to see probably 5094 and 1756 adopt concurrent communications, and that additional adapter will go away. But for now, this is one of the things that when you're designing a system, you need to be aware of.
Yeah, it would be, in my experience, uncommon to mix the IO in a new application.
Yeah,
but
it all depends.
You want to have that flexibility.
Yeah, you want to have that flexibility. Some people might say, well, I have this side of my process plant that needs fault-tolerant IO, and I have this balance of plant and so forth stuff over here that I'm going to use maybe smaller package in the standard Flex IO platform, right? And the nice thing is that with our controllers, you can mix and match different IO platforms. Just some of the design things that we need to make sure customers are aware of.
And just to reiterate, the only gotcha here is you need another network card just one other network card for the non-FLEXHA I/O. They can coexist on the same switches. We're using the same Ethernet network, same switches. We just need a separate card in the redundant chassis.
Correct. Yes.
Cool.
All right. And then this is showing DLR. And once again, it's the same network, just like those network switches, but there's two adapters in the controller chassis, and one of them is configured for concurrent communications, and the other one is not. But you can see you have 56 and 5015 all in that same DLR. It's just the adapter that's non-concurrent communications is talking to 56, and the adapter that's concurrent communications is talking to 5015. So in this case, the network is just like the network in PRP. It's the same. It coexists. It's just the adapter that is talking to it. The I/O needs to have two of them. Hey, I've been talking for almost an hour. I want to give Chris a chance to talk a little bit about Plan PX and some of the project execution things that are really important with Universal I/O. Remember at the beginning, I mentioned that there's I look at it as two type of I/O people. You got the traditional I/O and the Universal I/O, and how those projects execute is totally different, and there's some cost savings in it. And let Chris go through that. Chris, you want to go ahead and take it away, and I'll drive for you?
Yeah, please. Thanks. So as Armand was saying, the advantages or the interesting capabilities that the Universal I/O provides gives us some new ways to think about how we execute projects, especially in those big, large process-related projects where you're implementing a DCS as part of that, like our Plant PX system. So with Plant PX, traditionally, you'd sort of go through this very serially oriented kind of workflow, right? You'd define and size your system. You'd start doing the design for your networks and your enclosures. You'd build your enclosures. You'd then go get into configuring it according to how you've designed that enclosure and everything. And you start doing your factory acceptance testing. When you're done with that, move on to installation, et cetera. And you can see that sort of that orange part of the curve down below. There's obviously costs and resources involved in all of that, and it doesn't get to be really nicely smoothed out. It's not, you're bringing in lots of resources at different times because of that serial nature, and it doesn't make for a really easily managed sort of project, and it can get strung out, especially when you start to think about things like late breaking changes. So at any point where you see those red X's where something has to change because you've learned some new fact from your end user, or the process has to change or whatever, you're now bringing people back in. You're doing all kinds of extra effort to then configure those changes, test them, all those sorts of things. So sort of that traditional approach is so very serial, and it just really can end up being time consuming and costly. So if you go to the next slide, you'll see that with Universal I/O, then now you have the opportunity to start doing things in parallel. And as soon as we start doing that, that allows us to schedule time, people differently, and obviously shrink that schedule so that you're certainly spending a lot less time, and it's much more predictable and a more easily managed project, because you're not relying on exactly how that hardware is configured, what I/O modules in which rack, or all those sorts of things, right? It's all software configurable now, where the I/O module is just universal in nature. So you're doing a lot of the activities in parallel that saves time. So then if you go to the next slide, there's other tool sets that we have associated here, for use with Plant PX or Rockwell products in general, that help with this focus as well, because now we've got pre-configured virtual image templates that allow you to put your system together quickly. We can start testing code using our FactoryTalk Logix Echo before we even have controllers. So that just enables us to continue down that path of how we do things in sort of a parallel fashion versus waiting for all that hardware to be ordered, put in place, staged, and available for use that way. Or worse yet, you're robbing from other projects in your integration centers and things like that to try and build things as you go, because that just affects how those other projects execute as well. And of course, we have tools on our new design hub that allows us to do a lot of this stuff in a, on the cloud in a very, shall we say, distributed fashion, where you've got users maybe all over the world, certainly all over the country, right? And they're able to get in and do a lot of configuration work that you might have otherwise done on site in an integration center or something like that, with the extra cost of travel, et cetera. So if you move on to the next slide, there's even more, right? Now imagine an enclosure that's been designed and built to meet all these sorts of needs with the new 5015 I/O platform with Universal I/O. Now you're not even having to design or build those enclosures. They're just something you order. And so now if you go on to the next slide, you'll see that allows us to then even make more of our activities in that project execution lifecycle parallel in nature. So we could potentially be, instead of manufacturing enclosures, we're just ordering them. They could even be installed before you've even gotten to the point of doing, say, factory acceptance test completions, right? So there's a whole lot of things that can happen in that project that's only going to, again, shrink that time frame of that project and make your costs much more understandable and predictable, so that you can execute efficiently and most importantly, quickly. I think that's it for me, Armand. If there's any questions, happy to take them, but otherwise I'll let you finish up.
Yeah. So what Chris just mentioned is really important to some of our customers. I think really all of our customers. It's how do I reduce the risk of my project execution? And you can see the risk involved in the parallel or in the serial type project execution. You can see the cost savings when you use Universal I/O, a standard cabinet, and do parallel activities, right? And the control system is usually the last thing that gets done, right? After everything's delivered and put in place, that control system, everyone's standing over your shoulder watching you program it to make sure it runs, right? All right, just recap. I have 2 slides, Shawn, and really a recap of the lifecycle management and so forth, and how 5015 and Universal I/O is going to help customers, right? So if you think about it from the Universal I/O standpoint, you have one I/O card to stock that takes care of all your 4 I/O types. That one I/O card can be anything it wants to be when you're looking at spares, right? So when you have 20% spares, well, it's really a lot less because you have one card that can do anything. If you look at removing insert under power for maintenance, the diagnostic information, the ease of wiring, the modular construction of the system, being able to add I/O bases online and let it grow as the life cycle of the project or the plant that you're working on or offshore platform you're working on. You can add I/O online and add more I/O bases to help manage that life cycle as everything expands. I just wanted to cover some of those key points there. I have a slide here that goes over where to find information, right? So QR code to take you to our website, and on that website, you'll find some important information like a starter kit that I want to make sure that everyone knows about, right? So we went open for customer orders in November of last year. We launched this starter kit program where if you order a starter kit, we'll give you 2 of the 4 UIO cards for free. So instead of worrying about, hey, what's the price of your starter kit? It's just like, hey, you're going to buy some of these components, or we're going to give you some free, and we're going to make that last for some period of time, right? So probably going to go at least another year. So you'll see information about that starter kit. I urge customers to go and take advantage of that starter kit, get one on order, get something you can play with to start sitting at your desk and getting familiar with 5015 so you can use it in a future product. There's a product profile that goes over some information. There's technical data if you're looking into for technical information. There's lots of videos, other webinars just like this one. And there's a product selection. So our IAB tools, our process system estimator, all those tools were done last October for you to design and configure a Plan PX system 5.2 using 5015.
Nice.
So all that stuff is out there. Encourage customers to go take a look at that. And that's the end. That's all I had.
Well, guys, I really appreciate it. Thank you for answering all my questions and bearing with me as I pummeled you with questions. And really appreciate Armand and Chris for coming on the show and bringing us up to speed on 5015 FLEXHA IO. Let me ask you this. You guys going to be at Automation Fair?
Absolutely.
Yep.
Automation Fair in Boston, right?
Yeah, Boston, which is only 2.5 hours from here. So I'm looking forward to it.
And Shawn, this is going to be a first of this Automation Fair type. We are actually doing 4 events at once at Automation Fair. It's going to be huge. It's 5 days of packed information for things that we used to have 2 or 3 events per year. This Automation Fair is going to be much larger than normal.
Well, I'll have to get somebody. I'll have to talk to Mario and get somebody from the Automation Fair group back on. We've had him on a few times in the past, but would love to let the audience know more about that. And yes, audience, I will be there, so I want to meet you if you're there. Not only presenters, not only guests, but also listeners. So I love meeting the folks out there. But no, Armand and Chris, you guys did a great job. Thank you so much for coming on the show and bringing us all up to speed on this. I really appreciate it.
Thank you, Shawn.
Thank you.
Well, I hope you enjoyed that episode. I know I did. And I want to thank Armand and Chris for coming on the show and bringing us all up to speed on FLEXHA. You know, I really think I have a good understanding now of how that product goes together and how it's wired and really just the whole design of the product. And I hope you do too. With that said, if you did enjoy this episode, please consider giving us a like and a sub. And if you want to follow me or get in touch, you can do so over at automation.locals.com. You'll also find all the courses from our sponsor at theautomationschool.com. With that, I want to wish you all a very happy, safe, and healthy day. And until next time, my friends, peace.